So in this lecture, we'll take a look at velocity and acceleration in cylindrical coordinate system. So you see on the diagram any point P, so consider a point here. This particular point P in cylindrical coordinate can be represented in 3D by three coordinates. Rho is like R in polar, okay, and then there is phi and there is Z. Rho is the distance from center to point P. Z is the distance from the axis Z to point P, and phi is this angle. So project point P on the xy plane. Here this is the projection of point P on the xy plane, so let me write it as P dash. Draw a line from origin to P dash. Then the angle that P dash vector, radius vector, makes with x-axis is called as phi. Here you can see the relation between x, y, z and rho, phi and z. What is x, y, z? You know that if you consider the Cartesian system, then this point P can also be represented by using x, y and z coordinate. But now that we have chosen to represent point P using coordinate rho, phi and z, so the conversion is this. Okay, you can clearly see the conversion. Now if this is made, then how are the unit vectors related to each other? Remember, when we looked at our 2D system where we related the unit vectors of Cartesian and polar. So remember what was r cap? R cap was cos theta I. Instead of I, let me write x cap. This is another notation for I cap, and it was sine theta y cap. Okay, this was the relation between polar basis and the Cartesian basis unit vectors. Okay, go through the previous lectures, you will remember this thing. Similarly, it is quite natural that we can have relation between rho x cap y cap. We can have relation between theta cap x cap y cap. So remember what was theta cap? Let me remind you, theta cap was found out to be minus sine theta x cap plus cos theta y cap. So you see somehow it is almost same here. Instead of theta we have phi. Okay, but you see there is no conversion between z because z of the Cartesian coincides with the z of the polar cylindrical coordinate system. Okay, so now that we have the relation, what we can do, we can find quantities like this: d rho cap divided by d rho cap divided by d phi. Okay, so to make an analogy, let me remind you that when we did this 2D Cartesian and polar, we found this. We found d r cap divided by d theta. What did we find? We find it was equal to theta cap. So remember this. In this way we also found d theta cap divided by dr, and what did we find? We find minus r cap. Okay, go back to the previous lecture. Similarly, we can also calculate such kind of terms, but here we have calculated many terms. Okay, but you see that all these terms are 0, so there is no use of calculating these terms. Actually only 3 terms are important: d rho by d phi, d phi by d phi, this two term, because even this is also 0. Okay, here also you see there were only two terms which was very important to us, this one and this one. So analogy is quite great, right? So if you have understood the past lectures, then this lecture is not so difficult. Okay, we did up to this much. Next what? Next is looking at the time derivative of the unit vectors. Let me remind you with analogy that apart from this, while calculating acceleration, we required the value of d r cap divided by dt. Okay, so if you remember, dr cap divided by dt was found out to be theta dot theta cap. Okay, and these terms were used in the acceleration calculation. Similarly, here also we can calculate rho dot. What is rho dot? This is nothing but del rho cap divided by del t. So we calculated at hand various terms like this, del phi cap divided by del t. So why are we finding all these terms? Because they will help us in calculating velocity and acceleration. This is clear. Now let us quickly look at velocity. This is the expression for velocity. Okay, so to calculate velocity, what we have to do? We have to do the derivative of r. Okay, so let us write r. So r vector can be written as rho cap plus z cap. Okay, this is how r cap is written in your cylindrical coordinate. So by using the same trick that we did before, do the time derivative, and you have to find rho cap dot is found here. Then you have to find z cap dot is found here. In this way you can do your calculations, okay, and you will find velocity. Now what? Now do the time derivative velocity to calculate acceleration. Here is our acceleration. So what we did, all we have to do is take derivative of this velocity that we already calculated. Okay, so you'll get various terms, and all these terms, if you need to evaluate, you need to use this, and also you need to use these quantities. So you can do this calculation yourself, and you find this acceleration term in the cylindrical coordinate system. You see, there are some accelerations that are directed in rho cap direction, some accelerations directed in phi cap direction, and accelerations directed along z cap direction. So this is what we did, is we did this cylindrical in actually 3D. Okay, so it is expected that you can do the same. We already did examples in 2D. Now try it out yourself to do the entire calculation in 3D as a practice, and try to match with these results.